Hello dear students, all of you welcome to Vidyana classes. Today we will discuss adjoint of a matrix. Definition of adjoint of a matrix. What is the definition of adjoint of a matrix? Let capital A equal to square bracket A ij be a square matrix of order n. Let capital A be a square matrix of order n. The adjoint of capital A is denoted by the adjoint of capital A, where capital A is the square matrix of order n. The adjoint of A is denoted by arg A and defined by arg A is equal to transpose of the cofactor matrix. Rj is defined by transpose of the cofactor matrix having element A, capital A, ij. A is a square matrix of order n. Adjoint of A is equal to transpose of the cofactor matrix having element A, ij, where capital A, ij is the cofactor of the element Aij, where Aij is any element of capital A. Capital Aij is the cofactor of the element Aij. Clear? Transpose of the cofactor matrix is called adjoint. Example, let capital A be a square matrix of order 2 having elements A, B, C, D. Cofactor of the element A, which is denoted by capital A11, which is same as the sign of A is positive into determinant. Deleting the first row and first column, it gives determinant of D. Determinant of a single element is itself, so it is D. Determinant of a single element is itself. Cofactor of the element B, which is denoted by A12. Element of first row and second column, its sign is minus. Determinant deleting the first row and the second column, it gives determinant of C. Determinant of a single element is itself, it is minus C. Cofactor of C. It is the element of second row and first column, which is denoted by its sign is negative. Determinant obtained deleting the second row and first column, it gives determinant having element B. Determinant of a single element is itself, so it is minus B. Cofactor of D, which is denoted by capital A to 2, element of a second row and second column, its sign is positive into determinant having element. After deleting the second row and the second column, it gives A. Determinant of a single element is itself, that is A. Clear? These are the cofactors of the elements. Elements A, B, C, D. Cofactor matrix of the matrix capital A. Cofactor matrix of a capital A is the matrix having elements capital A 1 1, capital A 1 2, capital A 2 1, capital A 2 2. Cofactor matrix of capital A. A11 is D. A12 is minus C. A21 is minus B. And A22 is A. Clear? What is Adjoint? It is the cofactor matrix of capital A. What is Adjoint A? Rj is equal to transpose of cofactor matrix having elements D, minus C, minus B and A, which is equal to transpose means rows changes to columns and columns changes to rows. It gives D, minus C, minus B and A. Clear? Clear? Adjoint of A is the transpose of the cofactor matrix. It is the cofactor matrix of a capital A. Clear? Okay. Direct method to find adjoint direct method to find adjoint of a square matrix of order 2. Direct method to find adjoint of a square matrix of order 2. Clear? In this example, it is a square matrix of order 2. In this example, we get adjoint of A gives place interchange of the diagonal elements. A is replaced by D and D is replaced by A. And sign of B and C are changes. The sign of B is minus B, C is minus C. Place interchange of A and D. D is replaced by A is replaced by D and D is replaced by A. In this example, we have A is the matrix having elements A, B, C, D. The diagonal elements are interchanged. That is main diagonal. It is the main diagonal. A and D are the elements of main diagonal. Place interchange of A and D. Place interchange. A will be D and D will be A. Place interchange of A and D. In this example, we have A is replaced by D and D is replaced by A. Clear? Sign change of B and C. Sign change of B and C implies RJ is equal to place interchange of RJ, place interchange of diagonal elements. A is replaced by D, D is replaced by A. Sign change of B and C, that is minus B and minus C. A is the square matrix of order 2. Its adjoint is defined by place interchange of the diagonal elements. A is replaced by D, D is replaced by A. And the sign change of B and C, that is minus B and minus C. It is the sign interchange. Gives the adjoint of the square matrix of order 2. Example, let X be a matrix having elements minus 3, 4, 5, minus 7. Implies arch X means place interchange of the diagonal elements. Minus 3 is replaced by minus 7, minus 7 is replaced by minus 3. Sign change of 4 and 5, that is minus 4 and minus 5. It is the adjoint of X. Clear? Next example. Let capital B is a matrix of order 2 having elements 1, minus 2, 3, minus 4. Arch B place interchange of the diagonal elements. 1 will be minus 4. Minus 4 will be 1. Place interchange of the diagonal elements. 1 is replaced by minus 4 and minus 4 is replaced by 1. Sign change of minus 2 and 3, that is 2 and minus 3. It is the direct method which is obtained from this example. Place interchange of the diagonal elements, sign changes of this diagonal, that is B and C. Clear? Clear? Okay. Write down. Next example, find adjoint A for a matrix of order 3. Cofactor of the element one, that is capital 1. Element of first row and first column. The sign of 1 is positive. Deleting the first row and first column, the determinant obtained 3, 5 minus 2, 4. Deleting the first row and the first column, determinant having elements 3, 5 minus 2, 4. Position as 12 plus 10, which is equal to 22. Cofactor of the element 0, that means element of first row, second column. The sign of the element 0 is negative. Deleting the first row and the second column, the determinant having elements minus 1, 5, 2, 4. Deleting the first row and the second column, its sign is negative, which is equal to minus 4 minus 10, which is equal to 40. Minus 4 minus 10. Cofactor of the element 2. It is the element of first row and the third column. Its sign is positive. Determinant having elements minus 1, 3, 2, minus 2. Element of first row and the third column. Deleting this row and this column. 2 minus 6. 2 minus 6, that is equal to minus 4. Cofactor of the element minus 1. It is the element of second row, first column. Its sign is negative. Into determinant having elements, deleting the second row in the first column, the determinant having elements 0, 2, minus 2 and 4. 0, 2, minus 2, 4. The sign of this element is negative into determinant having elements 0 to minus 2, 4, which is equal to 0 plus 4, which is equal to minus 4. Cofactor of the element 3. That means element of second row, second column. Its sign is positive into determinant having elements deleting the second row and the second column into determinant having elements 1 to 2, 4. 2, 4. It gives 4 minus 4, that is equal to 0. Clear? Okay. Cofactor of the element 5, which is denoted by, it is the element of second row, third column. Its sign is negative into determinant having elements deleting the second row and the third column. The determinant obtained having elements 1, 0, 2, minus 2, which is equal to minus of minus 2 minus 0 is equal to 2. Cofactor of the element 2, which is denoted by, it is the element of third row and the first column. Its sign is negative into determinant having elements 0 to deleting the third row and first column. The determinant obtained having elements 0, 2, 3, 5. Clear? Minus of 0 minus 6 is equal to 6. Cofactor of the element minus 2, which is denoted by, it is the element of third row, second column. Its sign is negative. Second row, it is positive. A31, its sign is positive. So it is positive. Minus 6. A32, deleting the third row and second column. Third row and second column. Third row, second column. Negative of determinant having elements second row, third row and second column 1, 2, minus 1, 5. Minus of 5 plus 2, that is equal to minus 7. Last, cofactor of the element 4, A33. Its sign is positive into determinant having elements deleting the third row and the third column. Determinant having elements 1, 0, minus 1, 3, which is equal to 3 minus 0, that is equal to 3. These are the elements of the cofactor matrix. Cofactor matrix of capital A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A, which is same as A11, that is 22, A12, that is 14, A13 minus 4, A21 minus 4, 0, 2, minus 4, 0, minus 4, 0, 2, minus 6, minus 7, 3, minus 6, minus 7, and 3. It is the cofactor matrix of capital A. Clear? Adjoint. RJ, adjoint of the matrix, that is transpose of matrix having elements 22, 14 minus 4, minus 4, 0, 2, minus 6, minus 7, and 3. Transpose of the cofactor matrix. Cofactor matrix of capital A is given by this. What is adjoint? Transpose of the cofactor matrix is called adjoint matrix. RJ. Transpose means rows changes to columns and columns changes to rows. It gives 22, 14, minus 4, minus 4, minus 6, minus 4, 0, 2, minus 6, minus 7, and 3. It is the adjoint of the matrix capital A. So it is the answer. Find adjoint matrix of A of order 3. It is the adjoint matrix of matrix having order 3. Clear? Clear? Okay, write down. Theorem 1. If capital A be any given square matrix of order n, then A into Rj is equal to Rj into A, which is equal to A determinant into I, where I is the unit matrix of order n. Here it is given by A is a square matrix of order n. I is also a unit matrix of order n. Both A and I have the same order. We have to prove A into Rj is equal to Rj into A is equal to A determinant into I. Given A is a square matrix of order n, let capital A be the matrix having elements A11, A12 dotted A1n, A21, A22 dotted A2n, AN1, AN2, dotted A N N. A is a square matrix of order n. Is a square matrix of order n. A is a square matrix of order n. Implies Rj. What is Rj? Transpose of the cofactor matrix is called adjoint matrix. Capital A 1 1, capital A 1 2, dotted capital A 1 n. Rows changes to columns and the columns changes to rows. A 1 1 A 2 1 A 2 2 dotted A 2 n dotted A n 1 A n 2 A n n. Rj is the transpose of the cofactor matrix of capital A. Capital Aij is the cofactor of small aij. Capital Aij is the cofactor of small aij. Matrices A and matrices K and Rj are of same order. A is a matrix of order n. Rj is also a matrix of order n. Implies A into Rj and Rj into A are defined. Clear? Since A is a matrix of order n and Rj is a matrix of order n, so A into Rj and Rj into A are defined. Now A into Rj, A is a square matrix of order n. It contains the elements A11, A12, A1n, A21, A22, dotted A2n, AN1, AN2, ANn. A is the square matrix of order n. Rj is also a square matrix of order n. Capital A 1 1, capital sorry capital add A11 A21 dotted A N1 A12 A22 dotted A N2 A1N A2N dotted ANN. It is also a square matrix of order n. Both A into Rj and Rj are defined. A into Rj, according to the principle of matrix multiplication, go through row 1, come down in column 1, multiply the corresponding elements and add them. It gives A11, capital A11 plus A12, capital A12 plus A1N, capital A1N. It is 0, it is also 0. That it is 0. Next, A1, capital A21. A22, capital A22. Plus dotted A2N, A2N, capital A2N. Dotted, it is 0. A1, capital A, sorry, it is also 0. It is also 0. It is 0. Dotted A1, capital A1. A2, capital A2. Plus dotted ANN, capital ANN. Clear? Since I1, capital J1 plus I2, capital J2 plus dotted IN, capital Jn is equal to A determinant if I is equal to J. If I is equal to J and 0 otherwise. Sum of the product of the elements of a row. Sum of the product of the elements of a row or column with the corresponding cofactors is equal to a determinant. If I equal to j and this value is 0 for other cases. Sum of the product of the elements of a row or column with the corresponding cofactors is equal to a determinant. It is one of the properties of determinant. Sum of the product of the elements of a row with the corresponding cofactors is equal to a determinant, otherwise 0. Sum of the product of the elements of a row with the corresponding cofactors is equal to a determinant, otherwise the result is 0. So it is a determinant 0 dotted 0 0 a determinant dotted 0. It is 0. It is 0 dotted a determinant. Clear? It is a determinant. It is also a determinant. It is also a determinant. Other elements are 0, which is same as a determinant into 1 0 0 0 1 0. It is 0 0 0. Sorry, it is 1. It is a unit matrix of order n. A determinant into I. Determinant of A is a scalar quantity. If a scalar is multiplied with a matrix, it will be multiplied in each element of the given matrix. So this is same as this. Implies A into Rj is equal to a determinant into I. A into Rj is equal to a determinant into I. Similarly, Rj into A is equal to a determinant into I. Therefore, A into Rj is equal to Rj into A. A into Rj is equal to Rj into A, which is equal to a determinant into I. Hence, the statement is proved. Clear? Are you clear? Okay, write down. Next, properties of adjoint of matrix. What are the properties of adjoint of matrix? Let capital A close bracket Aij be a square matrix of order n. It is a square matrix of order n. And A is non-singular. That is DTA. That means determinant of A. DTA. That means determinant of A not equal to 0. The matrix capital A is said to be non-singular if determinant of A not equal to 0, otherwise singular. If DTA equal to 0, then it is called singular. If determinant of A not equal to 0, it is called non-singular. Capital A is a square matrix of order n. A is non-singular, that means determinant of A not equal to 0. Properties of adjoint of matrix. First property, adjoint of Ka which is equal to k to the power n minus 1 into Rj. Adjoint of Ka is equal to k to the power n minus 1 Rj, where A is a square matrix of order n and k is a scalar, where k is a scalar. It is the first property. Second, determinant of A into Rj is equal to A determinant whole to the power n. N is the order of the matrix capital A. It is the second property. Third property, determinant of Rj is equal to A determinant whole to the power n minus 1. Fourth property, determinant of Rj. A is replaced by adjoint A, which is same as A is replaced by Rj, which is same as Rj determinant of Rj whole to the power n minus 1. A is replaced by adjoint A, but determinant of adjoint A is equal to A determinant whole to the power n minus 1. Adjoint A is equal to determinant of A whole to the power n minus 1 to the power n minus 1, which is equal to determinant of A whole to the power n minus 1 whole square. This into this. It is the fourth property. Fifth property, Rj is equal to A determinant whole to the power n minus 2 into A. It is a scalar. Scalar into matrix is a matrix. Adjoint of Rj is a matrix. Sixth, adjoint of A transpose is equal to transpose of adjoint A. Adjoint of A transpose is equal to transpose of adjoint A. Property 7. Adjoint of AB is equal to adjoint of B into adjoint of A. These are the properties of adjoint of matrix. Adjoint AB is equal to adjoint B into adjoint A. Clear? Adjoint of K A is equal to K to the n minus 1. Adjoint A, where A is a scalar, n is the order of the matrix capital A. Determinant of A into adjoint of A is equal to A determinant whole to the power n. Property 3, adjoint of A is equal to adjoint of A whole to the power n minus 1. Property 4, adjoint of adjoint A and its determinant is equal to A is replaced by adjoint A. A is replaced by adjoint A whole to the power n minus 1. But adjoint A, determinant of adjoint A is equal to A determinant whole to the power n minus 1 whole to the n minus 1, which is equal to determinant of A whole to the power n minus 1 whole square. Rj is equal to A determinant to the power n minus 2 into A. Adjoint of A transpose is equal to transpose of A adjoint A. Adjoint of A B is equal to adjoint of B into adjoint of A. Verification. Let us verify property 7. Let us verify property 7. Property 7. Similarly, other properties can be verified. To show, to verify, to verify adjoint of AB is equal to adjoint of B into adjoint of A. We will verify property number 7. Let capital A be a matrix having elements 1, 2, 3, 5. B is a matrix having elements 3, 4, 5, 3, 4. Suppose it is 2, 3, 4, 2, and it is 1. Let capital A be the matrix having elements 1, 2, 3, 5. B be the matrix having 3, 4, 2 and 1. Here where A and B in this property A and B are two non-singular matrices of same order. Property number 7. Adjoint of A B is equal to adjoint of B into adjoint of A, where A and B are two non-singular matrices of same order. A, its determinant dta implies dta 5 minus 6 dta 5 minus 6, that is equal to minus 1, not equal to 0. dtb 3 minus 8 minus 5, not equal to 0. Property number 7 is true whenever A and B are non-singular. Implies capital A and capital B are two non-singular matrices. Now to show did adjoint of A B is equal to adjoint of B into adjoint of A. AB A means 1, 2, 3, 5. B 3, 4, 2, 1. By the multiplication rule, go through row 1, come down in column 1, multiply the corresponding elements and add them. 1 into 3, that is 3. 2 into 2, that is equal to 4. 3 plus 4, that is equal to 3 plus 4. Go through row 1, come down in column 2, multiply the corresponding elements and add them. 1 into 4, that is equal to 4. 2 into 1, that is equal to 1. Next, go through row 2 and come down in column 1. 3 into 3, that is equal to 9. 5 into 2, that is equal to 10. Next, go through row 2, come down in column 2, it gives 3 into 4, that is equal to 12. 5 into 1, that is equal to 5. Clear? 1 into 3, 2 into 2. 3 plus 4. 1 into 4, 2 into 1. 1 into 4, go through row 1 into 3, 3, 2 into 2, that is equal to 4. 1 into 4, 2 into 1, that is equal to 2. It is a 2. Go through row 1, come down in column 2. 3 into 3, that is equal to 9. 5 into 2, that is equal to 10. 3 into 4, that is equal to 12. 5 into 1, that is equal to 5. Which is same as 7, 6, 19 and 17. Clear? Implies this D. Adjoint of AB. Adjoint of AB is equal to, what is adjoint? The transpose of the cofactor matrix. By the direct method, we can find out the adjoint of a square matrix of order 2. It is a square matrix of order 2. So we can find out the adjoint by the direct method. The elements of the diagonal elements are placed interchanged. Place interchange. 7 and 17 are the diagonal elements. By the direct method, the elements of the diagonal elements are placed interchanged. It is the sign changes. Sign changes. Adjoint of AB. Place interchange of the elements, place interchange of 7 and 17. Sign changes of 6 and 19. So adjoint of AB. 17 place interchange of the diagonal elements. Place interchange of the diagonal elements. 17, 7. Sign changes -6 and -19. Clear? It is the adjoint of AP. Next, adjoint of B into adjoint of A. What is the adjoint of B? Place interchange of the diagonal elements. That is 1, 3. Place interchange. Sign changes of 4 and 2. That is -4 and -2. It is the adjoint of B. Next, adjoint of A. Adjoint of A. Place interchange of the diagonal elements. 5, 1. Place interchange. Sign changes of 2 and 3. -2 and -3. Adjoint means transpose of the cofactor matrix. By direct method, the diagonal elements are placed interchanged and the sign changes of 6 and 19. It is the place interchange, it is the sign changes. Now multiplying the two matrices, 1 into 5, that is 5, -4 into -3, that is equal to 12, it gives 17. 1 into -2, that is -2. 1 into -2 is equal to -2. -4 into 1, that is -4. It gives -6. Next, go through row 2, come down in column 1, -10, -2 into 5, 3 into -3, that is equal to -9. It gives -19. Next, -2 into -2, that is 4. 3 into 1, that is equal to 3. Which is same as 12 plus 5, that is 17, -6, -19 and 7. RGB into RJ is equal to matrix having element 17, -6, -19, 7, which is equal to adjoint of AB. Therefore, adjoint of AB is equal to adjoint of B into adjoint of A. So, the statement is verified that true. Adjoint of AB is equal to adjoint of B into adjoint of A. Similarly, we can verify the first 6 properties as 7. Are you clear? Okay, write down.